Great, so today we're going to take a look at section 1.2 and probably half, we'll see what we get through on section 1.3. So the first thing I'm going to show you is just kind of some general steps to think about in your head when you're trying to solve a word problem. There's steps you probably already do, and if you don't feel you need to write them, that's fine, but just kind of some general tips. So the first thing is, when you read the problem, kind of organize the information into two things. What do they want me to find? What are they giving me? Okay? So what do you already know? What do they want you to find out? That's the first step. So the next thing is to kind of figure out how you're going to solve the problem. Okay? Some problems kind of lend themselves to a picture, like the one we went over in the homework with trisecting a line segment. Some problems, a list might be helpful. Like if I said to you, tell me all the different ways you can arrange the letters ABC. ABC, BCA, CAB, things like that. You might make a list and then count all the ways. Now what can be a little impractical about a list? What can happen? Yeah?
You can repeat something if you're not paying attention.
Yeah, you might repeat something, and when would it be really hard or start to get harder to remember if you have already done that one? If what starts happening to your list?
There's more things that you need to write down. Like
yeah, there's a lot of things. Let's say I said, I want you to take the letters A through L and arrange them every possible way. Actually, just tell me the number of ways you can arrange them. Making a list is not a good way because there's probably hundreds of thousands or millions of ways you can do it. So list, not the best way. So making a picture, making a list, setting up an equation, that's what happens most of the time. Sometimes it's a problem involving like distance, rate, and time, or something like that. So using an equation. In page 13 in your book, they have a bunch of other suggestions for ways to kind of tackle a problem. And then carry out the plan. Okay, so once you make your equation, now you do the actual algebra and you solve it, okay, or whatever it is. Okay, so we'll try going through this in a word problem right now. All right, so we've got a company that charges $15 to rent a car, and then they charge a 20-cent, $0.2 fee per mile you drive it. So if I'm going to set up an equation for that involving something with miles and the initial cost, how many variables do you think I would need to set up an equation to figure out the cost to rent a car from this company? Yeah? And what would that one variable represent?
miles.
Miles. Is there anything else, though, that's going to change that's dependent? Our dependent, so that's our independent variable, because you can control how many miles you drive, but the what depends on how many miles you drive.
The total cost.
The total cost. So the two things that are going to change are cost, which is our dependent variable, because the cost depends on how many miles you drive. Cost is dependent. If you say miles is dependent, that doesn't make sense. How many miles you drive depends on the cost? No, if you got to go somewhere, you got to go there, you're driving there, so the cost is going to be how many miles you have to drive. That's cost is dependent. Okay, so in this case, I've already written down the two letters I'd like you to use. So let's set up an equation. Okay. Anyone think they can give me an equation to give me the total cost? Yeah?
Y equals 0.2x plus 15.
Yeah, 0.2x plus 15. And if you look at that, it's perfect. What format is that equation in?
Y equals
Y equals,
mx plus.
it's mx plus b, right? It's basically a slope and a y-intercept. Even though you might not think of the initial cost as a y-intercept, that's what it really is. Okay, so now we can use the model to do something, right? So we looked at the problem. We figured out they want an equation because they specifically set it in the direction, write an equation, so you're not making a list or drawing a picture. We made our equation. And now let's find the cost if we drove 50 miles. Okay, so Tori, what would I plug in for, or which variable am I going to plug in for?
You're going to plug in 50 for x.
We're going to plug in 50 for x. Okay, so we get 0.2 times 50 plus 15. And that's going to give me a cost of how much? Yep. $40. Let's see, so 2/10 of that would be, yep. So everyone agree with $40? I'm thinking 2/10 of 50.
I got 10 plus 15.
10 plus 15, right? It should come out to 25. Okay. Any questions on that? The pen will randomly change color like it did on the 5. No idea why. Does it all of that. All right, 100 miles. Double the distance, double the cost, right? It should just be $50. Does that reasoning make sense? Well, if you want to rent a car from me and pay me that money, I'll take it, but you shouldn't be paying me double. It's not going to work. Why isn't it going to work that way? Yeah?
Because you're not doubling the $15.
You shouldn't be doubling the initial fee, right? That $25 includes the initial fee and the mileage all in one. All you're doubling is the driving distance cost, not the initial fee. So 0.2 times 100 plus 15. Okay, and what does that come out to? About Ashley?
$35?
Yeah, $35. So definitely not double. It's not 50. So $35. Okay. So there's that. Any questions on just plugging something in and then evaluating? So this equation right here is what we call the algebraic representation for our problem. If somebody were to walk in the room right now and I showed them this, they would have no idea that that's about a car that costs $15 to rent and 20 cents per mile. This is more abstract. It's just an equation. So it's the algebraic representation of the problem. So when you do homework, if you see directions that say find an algebraic representation for a problem, it means to just come up with an equation to model whatever they want you to model. Now, we also got to be careful when we think about the domain of this, which is the numbers you plug in for x. Again, if somebody were to walk in right now and I said, what numbers could you plug in for x? They'd say anything. You can take any number you want, multiply it by 0.2 and add 15. But we know x is an amount of miles you've driven. So there are certain numbers that don't make sense. You couldn't, yeah? Yeah. Mathematically, you could do negative 10 times 0.2 plus 15. But in our problem, negative 10 is not in the domain. It doesn't make sense to use negative 10. Right? So when we graph things on the calculator, we have to keep in mind restrictions from the word problem. So let's suppose that Sarah was charged $50 for renting the car. How many miles did she drive? Okay, what are we doing that's different now? It's similar to what we did, but not exactly the same. Yeah, Kathleen?
You put the 50 number 1 instead of x.
Right, now we're going to say 50 equals 0.2x plus 15. Actually, I'll just do it down here. Okay, so to solve that, Gabe, can you tell me my first step? Gabe, sorry. Gabe B, I'll figure it out.
Subtract 15.
Subtract 15. Yep. So 50 minus 15 gives me 35. And Gabe K, what do we do for my last step?
Divide 0.2 by both sides.
Divide by 0.2. Okay, so dividing by 0.2. 0.2 is a fifth, so it's really like multiplying 35 times 5. That's going to come out to 175. And what is that again? 175 miles, not dollars. You drove 175 miles. So that's an algebraic way to do it. Not that bad. Pretty straightforward. Okay. Now I'm going to show you how you can do the same thing on the calculator. So I'm going to take the same equation you just had. 50 equals 0.2x plus 15. Okay, to do this, what I'm going to do is treat this and this as two separate things. So I'm going to turn my calculator on. I'm going to go to y equals, and if there's anything in there, you can just clear it. And you have several spots where you can type stuff in, y1 through y9. I'm going to type y1. I'm going to type 50 in for y1, and I'm going to type 0.2x plus 15 in for y2. So it's kind of like I'm graphing two things. And if you've got two pictures and you want to know where two pictures or two graphs are equal to each other, what does that really mean? Where two graphs are equal is where the graphs do what? Yeah. Where they meet. It's going to be where they cross. So I'm going to look and see where 50 is equal, or where the graph crosses 0.2x plus 15. 0.2x plus 15. So you should put it in just like that. And I usually start with a standard window, zoom 6. And nothing. Did I do something wrong? What's wrong? Yep.
Not zoomed out enough.
Not zoomed out enough. It's way off the screen. Right? If you graph y equals 50, that's a horizontal line at 50. So the first thing we got to do is make which value higher? The x min, x max, y min, or y max? Yeah. The y max has to be higher. And what I like to do is I don't like to put it right at 50 because then the line is right on the edge of the screen. Go a little extra. Go like 60. You could go 70. Just go a little more. Now we're going to see something. Okay, so let's hit graph. There's the horizontal line at 50. It's just a question, are we going to be able to see far enough to the right? No. And of course we can't see far enough to the right because we already know the answer. These graphs cross when x is at 175. Our highest x value right now is only 10. So because we know it's 175, we can just kind of cheat and let's just do 200. But if you didn't know it was 175, you would just have to try bigger and bigger x values until you finally get one where you can see the intersection. So there's your y equals 50 in y1. There's your 0.2x plus 15 in y2. And the important thing is we can see where they cross. So the calculator can automatically figure out what that point is. Okay? And the way you do it is you press second, calc. Okay? Calc is right above the trace button. Okay? Once you press second calc, you should be at this menu. Anybody that didn't get to this menu? Yeah. Did you press second and then trace? You got it, okay. So we want to find where the two lines cross, so which one of those options do you think we want? Well, Rachel?
5.
5. Intercept. So you can just press 5. And now it's going to ask you a couple questions. When you graph, you can have up to 8, 9 graphs on the same screen. So maybe you've got a bunch of lines. We only have 2. First, we got to tell the calculator what 2 lines we want to find an intersection for. We don't have a third one, but we still have to tell it which 2. So it says, what's your first curve? Okay. We're going to use the blue one, and we hit enter. Okay. Tell me the second curve, which in this case it's a line, but that's fine. Find the second curve you want to intersect. Hit enter. And the third thing is a guess. Now, for this problem, the guess is not really that important, because how many times are those 2 lines going to cross? Like even if we zoomed out forever.
1.
Just once. Now, if you had something like a line, like a parabola in a line, that's different. Now you could have 2. Well, the calculator can only find 1 intersection point at a time. So you want to put your guess close to the intersection point you're looking for. Again, in this case, it doesn't matter, because there's only 1 anyway. But put the guess somewhat close, hit enter, and then you should see that right there, when x is 175. So it's exactly the same thing we got algebraically. Okay. Questions on what we just did, or anyone need some help with finding that intersection?
Yeah, could you do that?
Do it again? Yep, so you got both your graphs. You press second, calc, you go to the 5th option, pick a point on the first thing you're going to use to find an intersection, pick a point on the second thing you're going to use, and then just use your arrow key, kind of go close to where they cross, and you hit enter. And then it tells you the intersection. Okay. Any other questions on that? Okay. So that's how you find an intersection between 2 lines. Now, if I had a third line in green, let's say doing something like that, now it would be important to tell the calculator which 2 lines you're using. Do you want to find where the green and the red cross? Do you want to find where the blue and the green cross? Like, what are you looking for? So then you'd have to be careful about which lines you pick. When you're picking the line, if you hit up or down, it'll allow you to change what line you're selecting. So you want the first curve to be the blue one or the red one? It doesn't matter in our case. Pick one. Just don't do that, because now you're trying to find where the red line crosses itself. That doesn't happen. So to find an intersection, you have to have 2 different things. Okay? If you pick a point and say, all right, tell me where the red line crosses the red line, it's not letting me do it. Okay? Where the red line crosses the blue line, sure, we can do that. And as I said, the guess doesn't really matter for this problem. Okay? Questions on how to do an intersection? All right. So that's the graphical approach. So, in the homework, when you see the directions, find a complete graph. That's a problem you can do on the calculator. If the directions say sketch or sketch by hand, that's something they'd like you to do on a piece of paper. Do it yourself. But if the directions just say find a complete graph, all they need to do is find a window that shows everything that's important in the problem. Okay, all the important features. I would say this is a perfect window for our problem. The important feature is the intersection point. If that's off the screen, you don't have a complete window or a complete graph. So if this was a homework and it said, tell me the window, I would just write down x min, x max, y min, y max. That's all I would write down to show that I have a complete graph. Just write those 4 values. Okay, so let's try that here. Let's graph y equals x squared plus 10 and find a complete graph. Okay, so 4 things you're going to tell me. X min, X max, Y min, Y max. So y equals, I'm just clearing everything out that was in there. X squared. If you make a mistake like I just did, just press the arrow to go back. Once it's highlighted, just press delete. Keep pressing delete until you get rid of what you don't want. So I meant to hit squared plus 10. Now let's start over with our window. I want to go back to the standard window. So does anybody remember what button I press to go back to the standard window? Yeah?
Zoom 6.
Zoom 6. Okay, so I know the calculator is working. The little yellow circle by the battery is turning, and nothing. So, does anyone have an idea of what I need to adjust in my window? I think you can do this problem with just adjusting one of the 4 numbers. Yeah, go ahead, Blake.
The Y max.
The Y max. This is a parabola that's been shifted up. So, what do you think it would be good to set it at? 20. Yep, I think that'll be perfect. So set your Y max to 20. And there you go. You're seeing all the important features of a parabola. As we get better with equations, you'll know that x squared plus 10 is a parabola, and that it's not like off the screen it's going to all of a sudden like turn and come back down. Parabolas can't do that. Okay. So if you can see the vertex for a parabola, that's the important thing to see. Okay, so write down your values. Negative 10 to 10. Negative 10, 20. That's what you have to write. Any questions on that? Okay. So that curve, I kind of said it a couple times now that we just drew, that's a parabola. And the general form of a parabola is a quadratic equation. Ax squared plus bx plus c. The a and b and c can be any real number, and depending on what you change, you can flip the parabola upside down, you can stretch it, shrink it, things like that. But that's called the general form of a parabola. Any question on that form? You've probably seen that when you do factoring and stuff like that. Okay. So let's find a complete graph here. The square root of x plus 20. So y equals second square root. That's how you do square root. You got to press second, and then it's the 5th button down on the left. What did I say? X plus 20. Now, before I hit graph, I'm going to do the zoom 6, but is there anything you're not allowed to do with square roots if we're sticking with real numbers? Something, Blake? You can't take the square root of a negative. Well, if x was negative 100 and I add 20, it'd be the square root of negative 80. So when x is negative 100, that's not going to be part of our domain. So that shouldn't be on our window. So let's just hit graph and see what happens. It's not a good picture because I know what a square root function is supposed to look like. It has a curve to it. Kind of like that. To me, if I look at that quick, it almost looks like a line. So that's not a good window. What's the smallest value you could plug in for x and not be taking a negative square root? A 0 square root is okay. But what's the smallest value you could plug in for x? Yeah?
Negative 20.
Negative 20. You can't go past negative 20. So let's set our window so we don't put it right on the edge of the screen. We can do negative 25, but we know we can't even go past negative 20. So let's hit graph now. There we go. Now I can tell that that's not a line. I can see the curved part. Some square roots curve more, some curve a little sharper, some not as sharp. But that's what a square root function should look like. Okay. And depending on how you do it, it can curve the other way, or it can curve on the bottom. But that's important to think about. Think about, okay, square roots can't be negative, so I can't go past negative 20. Now think about the other way. How big of a number can you take the square root of? Well, Emily? Any thoughts? How big can you go if you want to take the square root of something? Well, Renee? Like, is there a number that if you gave me, I'd say, no, that's too big. You can't take the square root of that. No, you can take the square root as big as you want. So no matter how far to the right you set your x max, you're never going to see the end of this graph. You can take the square root of 1,000,000, billion. It just keeps going. Right? So there's no upper limit on this graph. More just a lower limit. All right, so when we talked about homework, somebody said, well, can you graph points? And I showed you one way you can kind of turn individual points on and off. You can't really graph points in a way that you can like do anything with them if you graph like a parabola or a line with it and say, hey, where's the point in the line cross? You can't really do that. But another way to graph points is in a table, okay, on the calculator. Has anyone done that before? All right, so I'm going to show you how to type these points in and graph them. All right, so I'll try to keep the calculator and the directions up at the same time. And we don't have to type them all in. If you can type in 2 or 3 of them, that's fine. It doesn't really matter. Okay, what I'm going to do is just quit, go back to the main screen. So to quit, second mode will get you out of wherever you are, put you back on the main screen. So the first thing it says is to press stat. So stat is 2 buttons, well, it's the second button down from the top in the third column. So press stat. After we press stat, it says go to edit. We're on edit right now, option 1, so just press option 1. And now we've got these lists. We've got L1 through L5. Okay. If there's anything in your list already, what you can do is just highlight the number and press delete. That's how you get rid of it. Highlight the number, press delete. Don't highlight L1 and press delete. Then we have to fix the calculator and get the whole list back. So don't do that. Okay, I'll show you what not to do. So I'll do it on L4. I just blew away list 4. So now I've got to reset something in the calculator to get that back. Okay. So now what we're going to do is we're going to use L1 and L2. Okay. We're going to type the x values in L1 and the y values in L2. So I'm going to type in -3, hit enter. -2, -1. If you don't want to type them all, don't type them all. Just type a couple. 0, 1, 2, 3. Now type the y values in L2. To get to L2, press the right arrow. Now we just type in -18, -2, 2, 0, 2, 2. If you kind of notice, it's a mirror image. Look at the y values. They're the same values, 18 and 18, just positive and negative. Same with the x values. Okay. Any questions on that stuff? Yeah,
It's not letting you put any numbers into the thing.
it's not letting you put in any numbers.
It just says error.
It says error. Let's take a look. Yeah, just type in a number and then hit enter.
I'm not trying to put in a negative, it didn't work.
Oh, a negative? Make sure we're using the right symbol for a negative. That's the one below the 3. If you're using, I bet you tried the minus sign. Yep, that happens a lot. Yep. Gotta use the button that's below the 3. Okay, any other questions? Okay, so now we've typed in a bunch of data. Now we're gonna look at it on the screen. So we're gonna press the Y equals button. And what we have to do is turn on one of our scatter plots. If you've got anything else in there, we can just get rid of it so it's not in the way. So I'm going to go to plot 1. And notice plots 1, 2, and 3, they're not highlighted right now. Go to plot 1, hit enter. And now plot 1 is highlighted. So what's going to happen, just watch this, don't press this. Plot 1 is going to make a scatter plot using list 1 and list 2. If for some reason I didn't use lists 1 and 2, I could change it. Okay? Maybe I used list 5. Okay? You've got a bunch of lists in the calculator. I had you use 1 and 2 because those are the easiest ones. They're right away in the screen. So my X's were in list 1 and my Y's were in list 2. You don't ever have to touch that unless somebody else goes in and changes this on you. But you can do like bar graphs, you can do different kind of graphs. I just want to leave it the way it is. So yours should look like that right now. Now, on your window, what's the largest and smallest X values we have? Start with the smallest. Yeah, Kaya?
-3 is the smallest and 3 is the largest.
Yeah, -3 for the smallest. So I might do -5 to 5 because I like to leave a little extra room on the screen. And I like my Y max already, 20. That's pretty good. Let's set the Y min at -20. And now hit graph. And what you'll see, if you did it the way I did it, is a bunch of points that look like that. And those are points that are actually on a curve, which we could find an equation for. The calculator could now actually say, here's the equation that would go right through all those points. We're not going to do that, but you could. So any questions on graphing points like that? Not really something you do a lot, but it's something like in science, if you had a bunch of data points and you have to find a curve that models your data, the graphing calculator can do that. Okay. All right. Oh, anyway, we did this, but I just didn't show you this step. Set your window, your mins and maxes, and then press graph. This I'm not going to go through. I just want you to watch this. But if I type in x cubed, again, you can just watch me, minus 3x. Watch what happens. That's exactly the equation that goes right through those points. Okay? Now, I gave it to you, but the calculator could have figured it out as well. There is a way to do it. Okay? I just wanted to show you that. So, any questions mainly on graphing points? Okay, so what I'm going to have you do, so I don't have to clear out 300 or 400 numbers myself, is on the calculator, press, easiest way to do this is, we'll just go to stat. You know what? Yeah, we'll do it this way. Go to stat, go to edit. Now, don't highlight L1 and L2. Just highlight a number like I have, and then just press delete. Just press it 8 times or whatever until you get rid of all of them. Okay, and then highlight the numbers in L1. and just delete. Okay, there's other ways to do it too, but you know, my calculator, I gotta fix it and get list 4 back because I deleted the whole list. So there is a way to fix that too. Did anyone accidentally delete L1 or L2? Perfect. Okay, so that's that part. All right, so last thing we'll finish up with, we're not going to get through this all today, is section 1.3, and that's on functions. So kind of going back to that rent-a-car example where Sarah rented a car. I use these terms, but we didn't really write them down, what X and Y are called. So X is your domain. It's your input. It's also called the independent variable. It's basically what you are allowed to plug in for. Y is the output. It's the dependent variable. It's also called the range. So just different names for the X and Y variable, most of which I think you've probably heard before. Does anybody remember the name of the test to see if something is a function? It's something you can do. It's 3 words. Okay, so we'll come back to that. Does anybody remember what a function is if you wanted to define it? Like certain graphs are functions, certain graphs are not. Depends. Anyone remember what has to happen for something to be a function? Yeah? Okay, there has to be like a predictable way you're getting the points, like y equals x cubed minus 3x. That curve, now I messed it up because now if you get something actually good, it's good that this happened. It's because I have the scatter plot on still, but I deleted all the data in it. So I'm going to go highlight plot 1, shut it off, because I can't use it. There's no numbers in it anymore, and now things are back to normal. But that's definitely a function. That's what I wanted to show you. So the idea, if something is a function, it means every input has one output. It means if you give me an x value, and I plug it into the formula will give you back 1 and only one y value. Wasn't that what always happens? No. Think of the square root problem we did in the homework. If you told me to take the square root of a number, I would give you back 2 answers. That's not a function. Okay? A function is you plug in a value for x, and you get exactly one value for y. Don't worry about that. Okay. Any question on that? All right. So the domain, just we've already said this in various ways, but just to kind of formalize it on the board, domain is what you are allowed to plug in. Range are the type of answers you get when you plug in the domain. So for our mileage problem, we've already said domain should not include negative miles. The range in our driving problem was the cost. Well, what kind of number will the cost always be to rent the car? Yep, okay. Positive, right? You never have negative cost in our problem. Unless the directions state otherwise, domain is always assumed to be a real number. Okay, so we're not thinking imaginary. That's what I'm saying. Complex and imaginary, don't think about that right now. So there's two different notations when you want to write something as a function. There's y equals notation, and then this one below it. Can anyone tell me how to pronounce what I just circled? Yeah, Chris?
A function of x.
A function of x, f of x. Yeah. So two different ways to write functions. You can write things either way. I don't really care which way you do it. I use f of x notation quite a bit. Like if I was doing a problem about how far have I driven, it would probably depend on how long I've been driving for and how fast I'm going. So I might use d of t, my distance that I've driven, as a function of time, assuming I drive the same speed all the time. So d of t. So we'll use that notation quite a bit. All right, I don't think we need to graph this one. We already know what a square root function looks like. Let's just see if we can figure out at least the domain without graphing it. So we already know you can't take the square root of a negative. So what's the smallest value you could plug in for x and still take the square root of a number that's 0 or higher? Yep.
3.
3. You can't go smaller than 3. So the domain is all x's greater than or equal to 3. Or another way to write it, using kind of the notation we learned yesterday, is all numbers from 3, and bracket means equal to, including 3, up to infinity. You can go as high as you want. But since you can never reach infinity, we always put a parenthesis on it. A bracket is a number you can actually be equal to and reach. So this means all numbers from 3 to infinity. Now, sometimes it is helpful to get the range to kind of see a picture. So the range is how high and low the graph goes. So it starts at 3 and it goes to the right forever. Let's look up and down. What's it look like the lowest value that that blue curve hits? Up to down. Oh, Joe?
0?
Yeah, it does hit 0. In fact, it hits it right here, 0.03. And how high do you think that graph is going to go?
3.
Well, let me go further to the right. Remember, it's not how high does it go on our screen. It's how high would it go if you could see it forever. So how high do you think it's going to go now? Help them out? Yeah.
To infinity.
Infinity. It's never going to stop going up. Okay? Think if x gets bigger and bigger and bigger, and you keep taking the square root of a number that's getting bigger and bigger and bigger, your answer just keeps getting bigger and bigger. It never stops going up. Okay? That's what I'm trying to show you in this curve. It's going up slowly, but it's still going up. So the range is all numbers from 0, including 0, because it will hit 0 right on the axis, and it goes up to infinity. So domain, how far left and right does your graph go? Range, how far up and down? This particular graph never goes negative. It only goes in the positives. Try this one. Just because it has absolute value, and I don't think I've shown you where that button is yet. All right, so to graph absolute value, so the directions just say find domain and range. Same as the last problem. Absolute value is under math. So that's right below alpha. Go to number. And the first option right there is ABS. Okay, absolute value. So math, number, and then ABS. And now we just type in exactly what you see inside the absolute value. X squared minus 4. Okay, any question on that? Yeah?
How do you say for absolute value hit alpha?
Math, number, and then ABS. You got it, Chris?
Yeah.
Okay. So let's just hit graph. I'm going to do zoom 6 just to kind of go back to the normal screen. And it kind of looks like a parabola, but the absolute value causes the part that would have dipped down here and be negative to kind of flip up. That's what absolute value does. It makes everything positive. So let's look at our domain. Okay, in domain, I don't even think you need a picture. What kind of numbers are you allowed to square? That's your domain. So what kind of numbers are you allowed to raise to the second power? Yeah. 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 You can take any number, positive, negative, fraction, decimal, 0. You can take any number you want and square it. So x, you know what? Let's just write all reals. What that means is if you say the domain is all reals, you have a graph that's going left and right forever. And this one is. Slowly. But what about the range? Does this graph go up and down forever? What do you think? Kaya, what do you think? What's the lowest value that it looks like it hits?
Negative.
Negative. So negative 4 would be right down there. Remember, up to down. Not sure. Anyone help out? Yeah. 0. Yeah, it doesn't go into the negatives. The lowest this graph goes is right there. 0. And then how high does it look like it's going to go? Yeah, right? Infinite. It's going to go up forever. You can keep zooming out, but it's never going to stop. So the range is all y values greater than or equal to 0, or you can write it that way as well. Okay, any question on that? Yeah?
So could you write all reals as like parentheses negative infinity?
Absolutely, you could definitely do this. I didn't do it, but you could have. Yep. All right, this we kind of already did. It's like, how do you plug something in and evaluate? So we did that in the rent-a-car problem. You just plug in the number and do out the calculations. I don't really think we need to go through that. So like if I wanted to plug in -2, f of -2, I guess I'll just do 1 to show you, means take x and change that to a -2, and then just do it out. So if I did -2 squared plus 1, what do I get? 5. That's it. If I plug in a, well, I get a squared plus 1. If I plug in x minus 3, that's a little different. If we did that one. What would you have to do with x minus 3 squared? Because that's not a number. How do you... plus 1. How do you do out x minus 3 squared? Okay.
Do you have to square both sides?
No, we just want to do something to what's in red on the right. Just what's on the right. Remember how we do that up? About round.
What was the question?
How do we do that out?
You probably just square x and square -3.
Nope.
I
Don't
don't
do
know.
that. Yeah,
You do x minus 3 in a parenthesis times x minus 3 in another parenthesis.
exactly. You have to FOIL that whole thing out. So when you FOIL that out, you should get x squared minus 6x plus 9, and then you still have a plus 1 on the end. Okay. Everybody okay with distributive FOIL? Okay. So just make sure we know how to do that. So x squared minus 6x plus 10 would be the final answer for that problem. It's a little different than doing a number when you have to FOIL it. All right, let's see what do we have. That's the last thing. So not everything is a function. And I told you there's a certain test it has to pass. And I said we'd come back to it. Does anybody remember what that test is? Some type of line? Vertical line test? Is that ring a bell, or some people a little bit? Yeah, you remember it? Yeah, so it's the vertical line test. So if you were to try to graph this, well, first of all, you can't graph something with y squared. You want to type it into the graphing calculator, you got to get y by itself. Okay, how do we get y by itself? Take the square root of both sides. Well, if I type that into the calculator, watch what happens. Y equals the square root of x. And I can't do plus or minus in the same thing. I have to do them separate, like that. Positive square root of x, negative square root of x. There's your positive. There's your negative. So now the problem we have with that is if I said to you, okay, x is 2. Tell me the y value. There's 2. When x is 2, there's a value up here, and there's another value down there. That's not a function. Okay? Notice if you put a vertical line, it hits the graph more than once. That's what makes it not a function. Okay, so the vertical line test basically says if you can draw a vertical line anywhere on a graph and it hits it more than once, it's not a function. So circle. Would a circle be a function? No. Hits it more than once. How about this? Is that a function?
Yes.
Absolutely. If I put a vertical line anywhere you want, it's never hitting the graph more than once, no matter where you put it. Horizontal line would hit it more than once. That means something else. Vertical line only hits it once. Any questions on that? Okay, so the homework tonight, first part is from 1.2. The second part is from 1.3. So page 20, 1 through 10, 18, 21, 29, 32, 38. And page 30, 1 through 8, 11, 13, 16 to 19, and 24. Okay, and that's due on the 10th. Okay, so that's due on the 10th.